when splitting data into quarters, it's sometimes helpful to visualize the result using a box plot, sometimes called a box and whisker plot. Okay? The idea is that the min-max and the three quartiles are drawn with lines, horizontal lines. Okay, so one here for the max, one here for Q3, for Q2, and for Q1, and then a line for the minimum. Okay, the values of Q1, Q2, Q3, they are enclosed in a box. And then there are lines going from Q3 to the max and from Q1 to the mid. So this is a box plot. It summarizes how spread out the data is in each quarter. Let me give you a cleaner picture to work with. Okay, so here's one that's a little bit cleaner. You don't have all the data there. Okay, the three lines in the box represent the first, second, and third quartiles of the data. The bottom line is the minimum, the top line is the maximum. Each section here, each section is a different quarter of the data. Notice that means each section here has the same number of data values, right? Each quarter has 25% of the data values. So what does the size here telling us then? This section here is a lot bigger, say, than this section here. What's the size telling us? It's not telling us how many data values there are. Each one of these sections has the same number of data values. Instead, it's telling us how spread out the data is. This section here, which looks much more compact, okay, that's telling us that the data values in that quarter aren't very spread out. Whereas the data values here are going to be much more spread out because that quarter is much larger. It is represented in the box plot in a much larger sense. So the data values are more spread out in that quarter. Okay? So that's what a box plot tells us. It tells us how spread out the data is. Though each section, each quarter has 25% of the data values, has a quarter of the data values. Okay? So let's look at a couple examples here. Okay? The following data are the heights of 40 students in a statistics class. Construct a box plot using R. In which quarter is the data spread out the least? In which quarter is the data spread out the most? Okay, so first off, how do we actually construct a box plot in R? Well, it's very simple. In R, all you do is you type box plot, one word, and then provide the list of data values you want a box plot out of, and the computer will do the rest. Okay, so let's take a look at this particular example here. Let's gather our data. So I'm going to combine these data values into a list. And let's put our list of data right here, comma separated, in between those parentheses. Okay, let's give a name to our list. These numbers represent the heights of 40 students in a statistics class. All right, so we will call this list heights. Call it whatever you want, but I like to often name my lists and my numbers what they represent, just as a reminder to me. Okay? And then we want a box plot of this list of numbers. So I'm going to type box plot, and all I do is I tell it what the list of numbers is that I want a box plot of. I've called my list of numbers heights, and so that's what I say. So I'm telling the computer I want a box plot of the list of numbers that I have named heights. And if I evaluate, it's going to give me a bunch of stuff up here that you don't have to worry about. But in particular, this picture right here is what we're going for. Okay, that is our box plot. And so from this, we could see our minimum value is right here. That's our minimum value. This line here is our first quartile. This thicker line here is our second quartile. Top line is our third quartile. And then the one at the very top is our maximum value. Okay? Now, what was the question asking us for? It asked us to construct a box plot and then use that to decide which quarter is the data the least spread out in, and in which quarter is the data the most spread out in. Okay? So the quarter where the data is the least spread out in is the quarter that's the smallest, is the most squished together. This quarter here is the smallest, right? We can agree out of these 4 quarters, that one right there is the smallest. That's going to be the second quarter. Okay, this one's the first quarter, second quarter, third quarter, fourth quarter. Okay, second quarter, it's between Q1 and Q2. Okay, which quarter is the largest? Well, if I look at the 4 quarters, it looks like to me that this top one is the biggest. It looks a little bit bigger than all the others, which means the data in that quarter is the most spread out. Okay, so this quarter here, which is the 4th quarter, that's where the data is the most spread out. Okay, so our answer is the data is the least spread out in the second quarter, and is the most spread out in the 4th quarter. Okay, and just to re-emphasize, these sizes are just telling us how spread out the data is. But both those quarters, independent of their size, they have the same amount of data. All this is telling me is how spread out the data is. Okay, let's look at one more example. Use R to construct side-by-side box plots for the 2 sets of data below. Which data set has the larger spread of data? Which data set is more spread out, in other words? Okay, so we're going to have 2 data sets. Now we can actually use the computer to construct the 2 box plots so they're side by side. All we do is call box plot, and then we just separate the different lists of values with commas. So x1 would be the set of data from our first data set. x2 would be the set of data from our second data set. Okay, so let's do this with the calculator. Okay, and I'm going to grab my first data set and store it in my first list. And I need to give it a name. I'll just call it data 1 for the first data set. Okay, and then I'm going to also want my second data set. So I copy that, and I'm going to combine it into a list. So I paste those numbers in between the parentheses, and I'll combine into a list. And I need to give this list a name. This is my second data set, so I'll call it data 2. Okay. And now we need to create a box plot with both of these side by side. Okay. To do this side by side, we call the box plot function again. But instead of just giving it one list of data, I'm going to put a comma and I tell it what the second list of data is too. And that way it's going to create 2 different box plots. One box plot for this set of data and one box plot for this set of data. And they'll be side by side, so they'll be easy to compare. So if I click Evaluate, I get a bunch of information up here, which I don't care about that much. I'm most interested in this picture down here. So I'm going to get that image and I'm going to paste it in here. Okay. So I have my box plot for data set 1. I have my box plot for data set 2. Now the question is, which data is most spread out? We can see data set 1 looks a lot more spread out generally than data set 2, right? There are places where data set 1 is going to be real compact. Right here, it's real close together right there, all the data right there, right? But generally, if we look from the minimum to the maximum, data set 1 is more spread out than data set 2. Okay. One note, notice these 3 little dots right here. Those are data values in data set 2 that are especially extreme. When creating box plots in R, sometimes rather than making the lowest value the minimum or the highest value the maximum, sometimes there are values that are really much further extreme than some of the other values in the data set. And sometimes it will exclude those from the main box plot and just include those as other dots to say, hey, these are also values, but they're a little more extreme. They're extreme enough that we didn't want to include it in the main box plot. Okay, so that's what those dots mean.